Okay, so question 4. The model for the average height of a eucalyptus tree is below, where T is time in years and H is the height in meters. Determine the height of the tree after 1 year. So if this is after 1 year, then that means that T is equal to 1. Just be careful that this years matches years here, because otherwise sometimes they'll give you months and they'll expect you to do the conversion. Okay, so let's just plug it in and see what happens. So H equals 6 plus 6 log with base 3, and we're putting in 1. Okay, so that is going to become 6 plus 6 times. Now we're going to work out what log with base 3, 1 is equal to. Now, I can never remember which one is 1 and which one is 0. So I just each time rearrange and see what makes sense. So 1 is equal to, log 3 will come across and become 3 to the power of x. What to the power of x will turn this into being 1? It must be 0. So that's 6 times 0, meaning that 6 is our height in meters. Okay, the time it takes for the tree to reach 18 meters of height. This time, h is going to be equal to 18. Again, check that that's meters and check that height is in meters. So meters, we're good, we're squared off, let's go. So 18 is equal to 6 plus 6 log base 3t. First thing I'm going to do is take this 6 across by subtracting. So now I've got 12 is equal to 6 log 3t. Take this 6 across by dividing by 6. So now I'm left with 2 is equal to log 3t. Capture this log and take it across by making it 3 to the power. And now I've got 3 squared is equal to t. Therefore, t is equal to 9 years. Pretty easy. I like the questions about logs. I think they're nice and straightforward. Okay. A particle moves along the x-axis with a position at time t given by this. Between our domain of 0 to 2 pi, calculate each time t for which the particle is at rest. So if the particle is at rest, that means that its speed is equal to 0. Okay, so I'm going to start by stating my function. Now, straight away, I can see I've got 2 t's in there and those 2 functions are multiplying. So we're going to use product rule to derive this to get to our velocity function. So I'm going to let u equal et, which means u dash is equal to, the derivative of this is 1, so it'll be 1 times et. So that's why it just stays the same. V equals sine t, meaning that v dash is equal to, sine derives to cos, derivative of the inside will come to the front multiply, so that happens to be 1 as well, which is why we're just left with t there. So now I can plug this into my formula, that our new velocity function will be given by this one times that one, et cos t, plus this one times that one, sine t times et. Let's make that a power. Well, oh no, we're drawing all over the place. Okay, whatever, we'll deal. Okay, so there should be a t in here, and e to the power of t. Okay, so we want to solve for when this thing is at rest, meaning that e is going to be equal, or 0 is going to be equal to t, or e, t cos t plus sine t et. Now currently it's too hard for me to simplify it at the moment, but what I can do is I can factorize something out of each of the expressions, because once I've factorized, I can use null factor rule to solve this. So if I take an et out of both expressions, I'm left with cos t plus sine t. Now I can make null factor rule, so 0 is equal to et. If I take this to the other side, ln 0 equals t, but that is a math error. Oh, I can't write with this little pad. Pretend that looks neat. Okay, so now I'm going to do the other one. 0 is equal to cos t plus sine t. All right, so we're looking for when cos is equal to 1 and sine is equal to 0, or when sine is equal to 1 and cos is equal to 0. So let's just keep rearranging. And that way we're just going to make one of them the subject. So I take this, let's just say I take sine to the other side. Okay, it doesn't matter which one you move around. So now all I have to do is look for the values that will make this true. So I'm thinking about my unit circle. We want cos t to be positive and sine t to be negative. This one, they're both positive. This one, they're both negative, so that's not it. Here, cos is negative, sine is positive. Down here, cos is going to be positive and sine will be negative. So that's the quadrant that we're going to be looking for. Okay, so we want them to be equal to each other, which means we want them to have the same value. The only place that happens is at 45 degrees. So I'm going to let it be negative pi on 4, and we'll just give that a quick check. We want it to be 0 to be equal to cos minus pi on 4 plus sine minus pi on 4. Cos minus pi on 4 is positive root 2 on 2. Sine pi on 4 is minus root 2 on 2. Therefore, that is correct. So then that is our solution. So that's it. I should double check the answers to make sure that's correct. Yeah, I'll do it later. I might add in an extra bit here or there. We'll see. Okay, so determine the coordinates of the maximum point of this function. Fx equals ln 2x divided by x, and x has to be greater than 0. So if I'm determining the point, the maximum point will occur when dy over dx is equal to 0, or when the gradient is equal to 0. That's, I found, the maximum point. So let's get deriving. Okay, so first thing I'm going to do is let u equal ln 2x. That means that u dash, or the derivative of it, the derivative of 2x is 2 divided by, the original function goes underneath. These will cancel. It's going to be 1 over u. V is going to be x, which means that v dash is equal to 1. Now, because they are dividing with our x's, we're going to be looking at applying quotient rule. So, for quotient rule, this one goes first, always v first. But you do have this on the formula sheet, so if you're not sure in the exam, just look at the formula sheet. So x multiplied by 1 over x, straight away, that's going to simplify to be 1, minus 1 times ln 2x, and that's all divided by x squared. So I'm going to start writing this out below. So 1 minus ln 2x all over x squared. Okay, so if I am going to be trying to find the maximum point, I'm going to let this equal 0 because I'm trying to solve for where it's equal to 0. So this one would come up and multiply, which will give you nothing. So 0 times x squared is still 0 because anything multiplied by 0 is always 0. So 1 minus ln 2x. Now I'm going to take this 1 across. Negative 1 is equal to negative ln 2x. Take this negative across, which is going to knock out that negative. So 1 is equal to ln 2x. Take the ln across, and it's going to become e to the power of 1. So now I'm just left with my little fun friend Euler. So e is equal to 2x, take the 2 across, and I'm left with e over 2 is equal to x. So that is my x coordinate of the maximum point. If I want to find my other one, Or, it's a coordinate. So I've got x, I need y. So f of e over 2 is going to be equal to this substituted back in up here. Got to put him back up here. ln 2 multiplied by e over 2 divided by e over 2. If it's divided by e over 2, that means that this little 2 is going to come up here. This one is going to cancel that one. So now I'm going to write out what I've got left. So 2 ln e over e. This, remember, whenever you have log with a base and its other number is here, that cancels to equal 1. So ln is really log with base e, so that's going to cancel to be 1. So see ya. So 2 over e. So the coordinate is going to be e over 2 and 2 over e. Okay, question 7. The spread of a flu in a certain school is modelled by the equation, where PT is the total number of students affected after T days, given the population at day 3 is 50. Determine the rate. Let's pull apart the question. The rate. Anytime I see rate, that means I want to do the derivative of it, because I'm trying to work out the rate of change of this thing here. So we want to find that. Currently our problem is we don't have the B. Now we are given this other piece of information, and that is when time is at 3, the population of sickies is 50. So let's start chugging and plugging back into this to try and work out the value of B, and then when I've done that, I can get the derivative of this function. So 50 is equal to 100 divided by 1 plus e b minus t. Now I'm going to take this whole thing from the bottom up here by multiplying it. So now I've got 50, 1 plus e b minus t is equal to 100. Take this to the other side by dividing by 50. See you. So that's going to leave me with 2 here. Now I've got 1 plus e b minus t is equal to 2. Take this across by subtracting. So now I've got e b minus t is equal to 1. And when I take e across, that's going to become ln 1 is equal to b minus, now we have a value for t. Minus 3. 3 is t. I could have replaced that right there. But, this is how it's worked out. ln 1. Let's just double check what that means again. So ln 1 is really like saying log with base e1. And if I make this over here x, I take this to the other side by making it e to the power of x. So then that must be equal to 0. Okay, because the only value that will give me there is anything to the power of 0 is always 1. Okay, so b minus 3, take this to the other side, so 3 equals b. So my function is going to be this 100 over 1 plus e 3 minus t. Okay, so I would argue that you could probably use quotient rule for this one if you really wanted, but it's not really the one that you want to be using. Anytime you see a fraction, you think quotient rule, but see how there's no t on the top with this one? That's how you know that you're not really going to need to do that. So when I calculate the derivative of it, I'm going to take this bottom part and I'm going to make it derivable. So let me write this. So it's going to become 100 bracket 1 plus e 3 minus t to the power of negative 1. Okay, and then I'm going to take the derivative. Now I'm going to leave the constant out the front so he doesn't annoy things. And I'm going to take the derivative of this part here with respect to t to get my function. Now, if you look at their working, I'm sure they've got a much nicer way of doing this because they probably left themselves enough space to do this question. But, you know, here we are. Okay, so chain rule. The derivative of the inside of the bracket here, that will vanish, and then I just have to do the derivative of e to the power of 3 minus t. So derivative of the inside of this bracket is going to be -1 times e, and then the power above this isn't going to change. So derivative of the inside, -1 times e3 minus t, multiplied by the derivative of the outside. When I take the derivative of this, this is coming to the front, -1, or times -1 there, bracket. The power up here is going to decrease by 1, making it -2, and then what was in the bracket originally just goes back in. Okay, so now I'm left with 100 times that will give me a -100e, this stuff, times that again will make it a positive. So it'll be 100 e to the power of 3 minus t. Because this has got a negative power, I'm going to represent it as on the bottom. So 1 plus e power of 3 minus t, bracket, bracket, and that'll be squared on the bottom. Okay, and that is the rate that the fluid is spreading at this time. Maybe I've misinterpreted that question. If it's the rate that the fluid is spreading at this time, that means I should take the derivative and then input it back in with my time. So here's the function for the rate. Next thing we're going to do, we're going to put that back in to get it, what the actual rate is. Really, we're finding the gradient at this time. So 3 minus 3 will make this 0. So we're going to let t equal 3. Next part of this question, substitute back in. That'll give me 100 on the top. On the bottom, I'll have 1 plus e to the power